All right, if we want to graph a square root function here, let's look at the parent function. So y equals square root of x. Let's pick a couple of intelligent numbers here. Right, so I'm picking perfect squares. That way when I say y is the square root of that, I can easily, negatives. I can easily figure out the square root. Square root of negative 1 is 1. Square root of 0 is 0. Square root of negative 1 does not exist. So as soon as we get negative, we don't have any more square roots. So this is one of those functions that starts at a certain point and continues on forever in one direction, kind of like a flashlight. Starts and then the light can go on forever. Only this bends, it doesn't go in a straight line. So let's graph those points for our parent function, which is going to be 0, 0. That's our starting point. 1, 1, over 4, up 2, over 9, up 3. That's the parent function. So then if we had something like this, just remember what your transformations do. This is a left 1, because it's inside, so it's horizontal. It's counterintuitive. And then this is going to go down, because we're like adding a negative 4, would be the same thing as like subtracting 4 over here. So that's outside the operation, telling us it's a vertical, and it is intuitive, so it's going to go down 4. So we move our starting point left 1, down 4. And now this stretches it by a factor of 3. So instead of over 1, up 1, it's over 1, up 3 times as much. So instead of over 4, up 2, it's going to be over 4, up 3 times as much as that. So from here to here is 6 units instead of the 2 units that we had on the parent function. Right? So let's get that out of there so I can clean it up. And then, so I'm kind of pretending like this is the x-axis and the heights are off of that. So then over 9 up instead of 3, it's going to be up 3 times as much. So 3 times 3 is 9 units off of there. So that is what it's going to look like for the one that we have graphed, or we have been given.